Hi everyone, I'm Michan, and today I'll be showing you guys how our database is designed and how it effectively supports our hackathon scenario. Okay, we chose a team as a hackathon and our database name is called Sunway Hackthon. Yes. Okay, next. Our team includes, we have 6 members and we have all girls. Yeah, it's all girls. Okay, next. We'll talk about our scenario. So our scenario is actually a large-scale hackathon happening in a university with many student teams working on different themes like AI, sustainability, technology, health technology, and each team has mentors to guide them. They develop a project and present it to their judges, and every participant attends learning sessions, and the organizers must manage all of this in a smooth and trackable way. So our system is actually built to support exactly this. Okay, our main goal for our project is to design a relation database that captures and manages all the key components of a hackathon, and so from the teams and participants to mentors to judges and evaluations. Okay, we actually wanted to ensure about the smooth data management, accurate participants, and project tracking, even with the clear evaluation and scoring system. Yeah, we just ensure a fair and square system. Okay. We actually designed 11 business rules for this system, and we use primary and foreign keys to enforce relationships. And we actually included junction tables like team mentor, this is the team mentor, and evaluation table to handle many-to-many relationships, such as one mentor guiding multiple teams or a judges evaluating multiple projects. So we actually ensured that the data integrity with the rules, like each team submits only one project and each evaluations include a score from 0 to 100. Okay, how do we address the scenario needs? We design a normalized and well-structured database. Our system ensures that every participant is properly tracked, and including their role, their team, and their session attendance. Projects are actually clearly linked to their teams and evaluations. So judges and mentors can be assigned efficiently with no duplication or confusion. So it supports real-time event insights like what we normally see in hackathon competitions. Okay.
Hi, I'm Simin, and I will explain the ERD, which shows the structures of our hackathon database. There are several main entities in our design. Teams host each team's ID, names and descriptions, and the PK is team ID. The participant entity stores details of each individual taking part in the hackathon, including participant ID, names, email, role in team, and team ID. The PK is participant ID, and the foreign key is team ID. The mentor entity stores information about the mentors available during the hackathon, including mentor ID, names, and email. Mentor supports teams that are not part of the judging process. The PK is mentor ID. Teams mentor is an associative entity that connects mentor to teams, and the composite primary key are team ID and mentor ID. The team entity represents the different teams or category available in hackathons. Each team has a team ID, names, and description, and the PK is team ID. The project entity represents the submissions created by each team. It includes project ID, title, description, team ID, and submission date. The PK is project ID, and the foreign key is R, team ID, and team ID. Judge info such as judge ID, names, and email. The PK is judge ID. Evaluation records the scores and comments given by judges for each project, and the composite primary key for these are project ID and judge ID. The session info entity tracks optional workshop or info sessions during the event. It includes fields like session ID, session title, date, and topic. The PK is session ID. The session attendance entity records which participant attend which sessions, and the composite primary key for this are session ID and participant ID. This is our ERD diagram, which shows the structures of our database. Now I will explain the relationship between the entities in our database. For team to participant is one-to-many, participant to teams is one-to-one. Team to team mentor is one-to-many, teams mentor to teams is one-to-one. Next, mentor to team mentor is one-to-many, while teams mentor to mentor is one-to-one. Teams to project is one-to-one, and project to teams are also the same. Project to teams is one-to-one, teams to project is one-to-many. Evaluation to project is one-to-one, while project to evaluation is one-to-many. Evaluation to judge is 1-to-1, while judge to evaluation is 1-to-many. Next, participant to session attendance is 1-to-many, while session attendance to participant is 1-to-1. Sessions info to session attendance is 1-to-many, while session attendance to sessions info is 1-to-1. This ERD accurately represents how data is organized in a real-world hackathon scenario. It clearly defines how participants, teams, and projects are related, and uses joint tables like evaluations and team mentors to handle many-to-many relationship properly. The design supports all core functions from team formation and project submissions to evaluations and mentoring. Lastly, it also ensures data consistencies by avoiding redundancy and enforcing relationship through foreign key. Our system includes all the essential features needed to manage a hackathon effectively. First, it enforces team size between 2 and 5 members. Each team submits one project and each project is evaluated by multiple judges. We also support mentorship, where a mentor can guide several teams. This is modeled with the team mentor table. Team must select one team from the available list. For participant interest, we use the session info and session attendance entities to track who attend which sessions. This allows us to analyze patterns such as which participants frequently join the same sessions, helping identify core interest areas or potential collaborators. Overall, our database structures make it easy to perform this task while keeping the data clean and consistent. That's all from me. Thank you.
Hi, I'm Julie. I will be explaining how we created the table and set up the database in our SQL script. We start with drop table to remove any previous table first. This helps prevent error when running the script multiple times. In total, we created 10 tables including like team, participant, mentor, team, and others. Each table has a primary key like team ID or participant ID to make sure every row is unique. We also used foreign key to build relationship between tables. For example, in the participant table, we use team ID as a foreign key to refer to the team table. In the project table, team ID links to the team table, and the evaluation table connects project and judge. This helps keep everything connected and make sure our data stay consistent. On the top of that, we add check constraint to control what kind of data can be inserted. For example, we use like T %sign to make sure every team ID starts with the letter T. Email must included and and a dot. Role in team, we only allow specific roles like team leader, developer, designer, presenter, data analyst, and programmer. So people can't enter random or incorrect roles. That's all for me. Now I'll pass to Kavina. Thank you.
Good day everyone. Today I will be presenting the data insertion part for our SQL project where we populated the database tables using insert into statements. We structured the data around a hackathon event, and the inserted records reflect realistic scenarios involving teams, participants, mentors, projects, judges, evaluation, and also sessions. The inserted data showcases how entities are connected through foreign key relationships. To begin with, in the teams table, we inserted 8 unique teams, each with descriptive name and project focuses such as cybersecurity, health tech, and even education. Then, in the participants table, we added over 30 participants. Each participant is assigned a role like team leader, developer, designer, or even presenter. They are linked to their respective teams through Team ID foreign key. For the mentors table, we inserted 11 mentors, each with their own mentor ID, name, and email address. The team mentors table connects mentors to the teams they advise, which demonstrating a many-to-many relationships. Next, in the project table, each team was assigned one project. This project included titles, description, and submission date. Every project is also linked to a specific theme like AI, big data, or educational technology using the team ID. In the teams table, we inserted categories to help classify the project domains. Then we added data for judges, where each has an ID, name, and email, and the evaluation table where judges score different projects. This includes the score, evaluation date, and even judge comments, which adds a human element to the data. This table showcases a many-to-many relationship since each judges can evaluate multiple projects and each project can receive multiple evaluations as well. We also included the session table representing events like workshops or mentoring sessions during the hackathon projects. These included sessions, session titles, descriptions, and dates. Finally, in the session attendance table, we track which participants attended which session. This link to the participant ID to the session ID, showing a many-to-many relationship again, which helps to stimulate the attendance monitoring. In summary, our insert into statement fills each table with structured and interrelated data. The foreign keys across tables like team ID, project ID, mentor ID, and session ID, which help enforce referential integrity. Overall, the inserted data doesn't just populate the tables, it tells the story of a full hackathon system, complete switch with participants, evaluation, and learning sessions. That's all from me. Thank you.
Hi, I'm Zishan, and for this project, I was working in part 2 to write 3 of the SQL queries, which is queries A, C, and E. And for the first one, I have to write a query that requires an outer join. I set up a situation to show all terms and the projects under them, which including terms are not assigned by any project. And in the table, I want to show the term ID, term name, project ID, and project title. For the outer join, I choose to use left join, and I order the table by the term ID so that it won't look too messy. And when I run, this will be the output, term ID, term name, project ID, and project title. Scrolling down, you can see this is the now. That means these terms are not assigned by any project.
Hi, my name is Chu Haijun. So for our group project, I was responsible for writing SQL queries B, D, and F based on the project database. So for query B, I was required to write a minimum 4-table join with a group by function query. So I will list each team and their average evaluation score along with their team name and sort the results from highest to lowest average score. So I decided to join 4 tables, which are team, project, team, and evaluation tables. I select to list each team, their team name, and calculate the average score their project received. So I use the average function to calculate the average score and the group by function to group the results by team and team. Then I use the order by function to sort the output in descending order to show which teams perform the best overall. So based on the results, as you can see from here, each team is listed here along with their project team, and the output is sorted from the highest average score to the lowest.
And for the second one, I have to show a string pattern matching and date function queries. I choose to show project submitted in July 2025 under help rated title. And in the output, I want to show the project title and submission date, and it should be submitted in 2025 July. And this is the only one project title which is related with health and submitted in July 2025.
Next, moving on to query D, I was required to write a query having both or and and. So I will find participants who are either developers or presenters and are from teams mentored by Ms. Chua. I first select to list participant ID, participant name, their role in team, and their team ID. I join 3 tables which are participant, team mentor, and mentor tables. Then I have condition where the participant's role in team has to be either developer or presenter, and their team mentor name has to be Ms. Chua. This is to ensure that we only get participants who match the required role and mentor. So as you can see from the results here, these 4 participants are having role either developer or presenter, and their team are mentored by Ms. Chua, which are team 1 and team 5.
And for the third queries, I have to show queries that consist of at least 2 subqueries, and I choose to find participants who work on project in the AI term. And 2 of these will be the subqueries. This one and this one will be the subqueries. And when I run it, this will be the output. These people is the participants who work on projects in the AI term.
Then moving on to query F, I was required to identify sessions that frequently have participants registering together, suggesting potential co-interest or related topics. So I first select to list session ID, session title, topic, and count the number of participants per session. Then I join sessions info and session attendance. I use left join, which is an outer join, to show every session even if there is a session that does not have any participants attending. Then I group the results by session ID, title, and topic using the group by function. And then I ordered them by the number of participants in descending order using the order by function. This helps us recognize sessions with high interest, which might reflect shared topics or future areas for focus. Then as you can see from the results here, each session ID is listed here along with the session title and their topic. and the output is sorted from the highest number of participants to the lowest.